Okay, here's your video on factoring polynomials completely. If I make a mistake, I'm probably not going to restart because this is going to be long. Just so you know, I'm following these steps that I gave you guys in the notes. It'll eventually focus. I clicked the button and it focused. I'm following these steps. I'm not going to keep showing these steps, but I am going to follow these steps. So I suggest whenever you're doing a problem, have this out. If you forget exactly what each step does, go back. Turn the page over. Use your notes. Don't be silly. First thing you want to do is you want to identify all the possible roots. You don't want to start testing any random number because it might not even work. You find your possible roots by first finding your p and then finding your q's. Your p's are not the constant, however, they are the factors of the constant. So p equals factors of the constant. In this case, the constant is negative 72. You don't have to write out all the positive and negative ones, but when you get to p divided by q, then yes, you do. Factors of 72, there's 1, 2. Is 3 a factor? Yes. 3. Is 4 a factor? Yes. There's 6. 7 is not. 8. 9. 6 times 12. 4 times 18. 3 times 24. 2 times 36. And 1 times 72. If you forget what a factor is, and this does happen and that's okay, a factor means it can, there's two possible ones. There's it divides it into another whole number, or you can say it multiplies evenly into a whole number. I'm going to use the division one. So it divides a number evenly into another whole number. The way you check that is 1 times 72 is 72, 2 times 36 is 72, etc. Q is easy. The leading coefficient is just 1, and the only factor of the leading coefficient in this case, on the second example, I'll have one where it's not, it's just 1. Which makes P over Q, in this case, rather simple. It's all of these divided by 1, plus or minus. So we have positive or negative 1, positive or negative 2, positive or negative 3, positive or negative 4. Every single one of these written out. I'm not going to write them all out because you don't have to write them all out. What's important is, I need another color, that you understand that in step 2, you start testing all possible roots. Let's say I test all these 8 roots out. There's 8 roots because there's positive and negative 1, that's 2 roots. Let's say you test all 8 of these roots and none of them work. And come back to your list and find another p divided by q. If none of these work, you would then go to the next one, positive or negative 6. My advice, eventually there's going to be a lot of fractions. Leave the fractions for the end. Maybe one day I wake up and I feel really mean and they're all fractions, but leave the fractions to the end. Let's start testing for now. Synthetic division. We've done synthetic division for a while now. You guys are really good at it. Give yourself a round of applause. The coefficients of the polynomial are 1, negative 4, negative 1, 36, and negative 72. First root I'm going to test. I'll be honest, I don't remember the answer to this. I made this function up last night, made sure it actually worked. I'm just going to test 1 first. So bring the 1 down, 1. 1 times 1 is 1. Negative 4 plus 1 is negative 3. Negative 3 times 1, negative 3. Negative 1 minus 3 is negative 4. Negative 4 times 1 is negative 4. 36 minus 4 is 32. 32 times 1, 32. This is negative 40, not a factor, because the remainder is not 0. So I'm going to go ahead and test a new root. Got 1, negative 4, negative 1, 36, negative 72. And I'm going to test negative 1. So bring the 1 down is 1. 1 times negative 1, negative 1. Negative 4 minus 1, negative 5. Negative 5 times negative 1 is 5. Negative 1 plus 5 is 4. 4 times negative 1, negative 4. 36 minus 4 is 32. 32 times negative 1 is negative 32. Negative 72 minus 32 is negative 104. Not a factor, because that is not equal to 0. So, next thing I would test is 2. If you want to test 3, 4, or 6, go ahead, be my guest. But I'm going to test 2 first. So again, same coefficients. Double check that you wrote down everything correctly. A lot of our mistakes are just little things, they're not even big picture things. So 1, 2 times 1 is 2. Negative 4 plus 2 is negative 2. Negative 2 times 2 is negative 4. Negative 1 minus 4 is negative 5. Negative 5 times 2 is negative 10. 36 minus 10 is 26. 26 times 2 is 52. Negative 20. Again, not a factor. Not a factor because that remainder is not equal to 0. Double check my work. 1, 2, negative 2, negative 4, negative 5. Right. Now I'm going to check negative 2. So I have 1, negative 4, negative 1, 36, negative 72. Check negative 2. Bring the 1 down. 1 times negative 2, negative 2. Negative 4 minus 2, negative 6. Negative 2 times negative 6 is 12. 2. I messed up. I didn't look at my paper. Realized it was a little out. I'm sorry. Please forgive me. 12 minus 1 is 11. 11 times negative 2 is negative 22. 36 minus 22 is 14. 14 times negative 2 is negative 28. And 72 minus 28. Negative 72 minus 28 is negative 100. Not a factor, because that is not equal to 0. I'm going to test 3 next. Wow, I was evil to myself. 1, negative 4, 1, 36, negative 72. This is a negative one. Again, double check. Make sure all your numbers are right. 3. So 1. 3 times 1 is 3. Negative 4 plus 3 is negative 1. Negative 1 times 3 is negative 3. Negative 1 minus 3 is negative 4. Negative 4 times 3 is negative 12. 36 minus 12 is 24. 24 times 3 is 72. We have found our first factor. Yay, factor, because the remainder is 0. So, keep track of your factors. Factored form. Keep track of your factors. Cannot stress that enough. We found our first root. If the root is 3, that means the factor is x minus 3. Next, we found our first factor. Now what? Now, when you check for more roots, use this new polynomial. So our new polynomial has coefficients. Let me write out the actual polynomial. Here, we now have f of x is equal to This was originally x to the power of 4, so now this is x to the power of 3. So 1x to the power of 3 minus 1x squared minus 4x plus 24. This is what we have left for now. I'm going to take these coefficients, 1, -1, -4, 24. We're going to test the 3 again, because we might have two factors of x minus 3, and there's no way of knowing that unless we test the new polynomial with that same root again. So 1, bring the 1 down. 3 times 1 is 3. -1 plus 3 is 2. 3 times 2 is 6. 6 minus 4 is 2. 3 times 2 is 6. 24 plus 6 is 30. Not a factor. That is not a factor. As we continue our synthetic division, we are going to continue using the new polynomial. So where's my purple? 1, -1, -4, and 24. Next, I'm going to test -3. So -3. Bring the 1 down. 1. -3 times 1 is -3. -1 minus 3 is -4. -3 times -4 is 12. -4 plus 12 is 8. 8 times -3 is -24. And 24 minus 24 is 0. Factor. Because, again, for the same reason here, the remainder is 0. So we have our second factor. If the root is -3, the factor that goes along with it is x plus 3. Also, we now have what we want. F of x is now x squared minus 4x plus 8. We have a quadratic. A quadratic is any polynomial where the degree of it is 2. We have a quadratic. Now you go back to first semester. Factoring a quadratic requires a diamond and sometimes an area model. In this case, a equals 1, b equals -4, and c equals 8. So we need a times c up here, b down here. We need a number that multiplies to 8 but adds to -4. Our options are 1 and 8, 2 and 4. Can we get -4 using these numbers? I'll give you some think time. And then I'll go get another paper because I was cruel to myself. The answer is no. You cannot factor this using the area model. The mathematical reason for that is x squared minus 4x plus 8 is not factorable over the reals. Learned about 2 number systems this year. You've learned about one your whole life, and we added a new one this year. We cannot use the reals. We are going to use imaginaries, meaning quadratic formula. So we're going to factor that quadratic. We're going to factor f of x equals x squared minus 4x plus 8 using the quadratic formula. We are going to have imaginaries. The quadratic formula is -b plus or minus the square root of b squared minus 4ac divided by 2a. There will always be a poster of the quadratic formula in class. This is not something I expect you to remember. I am not my teachers. A was equal to 1, B is negative 4, and C is 8. So just substitute. We have negative 4 plus or minus negative 4 squared minus 4 times 1 times 8. All divided by 2 times 1, which is equal to 4 plus or minus the square root. Negative 4 squared is 16 minus 4 times 1 is 4 times 8 is 32. All divided by 2 times 1, which is 2. So to simplify this further, we have 4 plus or minus the square root of negative 16 divided by 2. This is equal to 4 plus or minus. The square root of 16 is 4. However, because of the square root, there's a negative under the square root, then I need 4i divided by 2. We're going to simplify this because 4 can be divided by 2, and 4 in front of the I can be divided by 2. So this ends up being 2 plus or minus 2i. So I have my two new roots. They are 2 plus 2i and 2 minus 2i. When you write these roots in factored form, so wait, where did it go? When we write them in factored form, we're going to write them like this. X minus parentheses 2 plus 2i, close the parenthesis and close the other one, and also x minus 2 minus 2i. This is your final form in factored form. Second problem. Second problem. I'm going to start over the same process. We find P, we find Q. P equals to the factors of the constant. We need factors of 108 now. There's 1, there's 2, there's 3, there's 4, there's 6. 6 times 10 is 6. Yes, 6 is 1. 7, 70 plus 38 is not 1, so no. Is 8. 80 plus 28, no. 9, yes. And then 9 goes with 12. 6 goes with... Let's remember what 6 goes with. I think it's 18. Yeah, 18. 4 goes with 40, 80, 27. 3 goes with 36. 2 goes with 54. And 1 goes with 108. Now Q equals factors of 4. So 1, 2, 4. Now every single possibility of P over Q. Again, we're going to make a short list. We're going to come back to the list if we need more factors. Pick a P value, divide it by a Q value. Let's pick some of the whole numbers first. So plus or minus 1, plus or minus 2, plus or minus 3, plus or minus 4. Let's start there. I'm not going to make out the whole list, but let's start there. Maybe we don't need more. Maybe we do. Let's see how evil I was to me last night. I don't remember. Oh, I was really evil. This is x to the power of 5. Huh. Okay. Synthetic division. We got 4, negative 4, negative 41, 57, 72, and negative 108. What are the odds that I chose 1? Let's find out. I'm going to test 1 first. 4 times 1 is 4. Negative 4 plus 4 is 0. 1 times 0 is 0. Negative 41 plus 0 is negative 41. 1 times negative 41 is negative 41. 57 minus 41 is 16. 16 times 1 is 16. 72 plus 16 is 88. 88. Negative 20. Not a factor. Next, we will check negative 1. 4, negative 4, negative 41, 57, 72, negative 108. This is the part where I tell you don't get discouraged if you check like 8 of them and they don't work. Because trust me, the further you go in math, the worse it gets. And you're going to love it. So 4. Wait till you get to a calculus problem and the problem takes 2 pages and the answer was just 1. That'll be fun. 4 times negative 1, negative 4. Negative 4 minus 4, negative 8. Negative 8 times negative 1 is 8. Negative 41 plus 8 is negative 33. Negative 33 times 1 is 33. 57 plus 33 is 90. 90 times negative 1 is negative 90. 72 minus 90 is negative 18. Negative 18 times negative 1 is 18. And this is definitely not 0. So not a factor. Also, I forgot to change colors. Sorry. Next test. We're going to check 2. 4, negative 4, negative 41, 57, 72, negative 108. We are going to check 2. So we have 4. 2 times 4 is 8. Negative 4 plus 8 is 4. 4 times 2 is 8. Negative 41 plus 8 is negative 33. 2 times negative 33 is negative 66. 57 minus 66 is negative 9. 2 times negative 9 is negative 18. 72 minus 18 is 54. 54 times 2 is 108. And negative 108 plus 108 is 0. We found our first factor. So factor. Woohoo! Because that equals 0. Keep track of your factors. Keep track of every single one. So factored form. Now, the degree is 5. How many factors in total will there be? If you said 5, good job. Our first one is x minus 2. F of x is now equal to 4x to the power of 4 plus 4x cubed minus 33x squared minus 9x plus 54. That is going to be the new polynomial that we are going to test. Again, you need the new one because if there are 2 x minus 2's, then you're never going to find it. Unless, of course, no, just keep assuming that. So 4, 4, negative 33, negative 9, 54. Let's test the 2 again. Bring the 4 down. 2 times 4 is 8. 4 plus 8 is 12. 2 times 12 is 24. Negative 33 plus 24 is negative 9. 2 times negative 9 is negative 18. Negative 9 minus 18 is negative 27. 2 times negative 27 is negative 54. 54 minus 54 is 0. Factor. I was kind to myself. Because that equals 0. So you have two options. When you write your factors form, you can write another x minus 2, or what I need you to get comfortable with is squared, because we have definitely two of those. If it turns out there were three of them, then I'll go back, put a 3, but for now there are two of them. Synthetic division, again with the new polynomial. So our new polynomial is now f of x equals 4x cubed plus 12x squared minus 9x minus 27. Synthetic division again. And the reason I'm using synthetic division again is this is a cubic, not a quadratic. We use synthetic division until we have a quadratic. So 4, 12, negative 9, negative 27. And I'm going to test 2 again, because maybe it happened 3 times. 2. To bring the 4 down, 2 times 4 is 8. 12 plus 8 is 20. 2 times 20 is 40. Negative 9 plus 40 is 31. 2 times 31 is 62. Negative 27 plus 62 is definitely not 0. So not a factor, because the remainder is not equal to 0. One of our next possible roots was plus or minus 3. So I'm going to check plus or minus 3. So 4, 12, negative 9, negative 27. And let's check 3. Bring the 4 down. 4 times 3 is 12. 12 plus 12 is 24. 3 times 24 is 72. Negative 9 plus 72 is 63. 3 times 63 is 189. 189 minus 27 is 162. Not a factor. Time to test another one. I'm going to test negative 3 now. So 4, 12, negative 9, negative 27. I'm going to test negative 3. Bring the 4 down. 4 times negative 3 is negative 12. 12 minus 12 is 0. 0 times anything is 0. Negative 9 plus 0 is negative 9. Negative 3 times negative 9 is 27. Negative 27 plus 27 is 0. Woohoo! We found a factor. Factor. If the root is negative 3, then the factor is what? If you said x plus 3, good job. Now our new polynomial is f of x equals 4x squared minus 9. I have a quadratic. In fact, we have a special type of quadratic. This is called a difference of squares, where 9 is a perfect square, because the square root of 9 is 3. 4x squared is a perfect square, because the square root of 4 is 2, and the square root of x squared is x. And it's separated by a minus sign. That's why it's called a difference of squares. So, if you learn the tricks from first semester, then you can skip along to the answer, which will be the square root of 4x squared is 2x. The square root of 9 is 3. You're going to have a plus and a minus version of it. If you cannot use the difference of squares method, in Math 3 Enhanced you will be expected to do it, then you use the area model. A equals 4, B equals 0, C equals negative 9. So we have a diamond. 4 times negative 9 is negative 36. 0. Well, adds to 0 but multiplies to negative 36. 6 and negative 6. And then you do your area model. In the top left goes ax squared, so 4x squared In the bottom right goes c, so negative 9. And then here goes 6x, the answers to the area to the diamond problem, and negative 6x. Now the greatest common factor between 4x squared and 6x is 2x. And now 2x times what is 4x squared? Well, that's 2x. 2x times 3 will give me 6x. And 2x times negative 3 will give me negative 6x. Final check, negative 3 times 3 is in fact negative 9. It's the same answers that I found earlier using the difference of squares. So my last two factors are 2x plus 3 times 2x minus 3. Now, if I ask you to sketch these roots, what you do, these I know we can handle. These, set each one equal to 0 and solve this two-step equation. Minus 3, 2x equals negative 3. Divide both sides by 2 to isolate x. X equals negative 3 over 2. This one of the roots. The other root is 2x minus 3 equals 0. Add 3 to both sides. 2x equals 3. Divide by 2 from both sides. X equals 3 over 2. So that when you go to sketch it, let's do it here. You have one root at 3 over 2. One root at negative 3 over 2. A root at 2 that bounces. I'm going to put a little b. And a root at negative 3. This is the only one that bounces, the rest cross. The leading coefficient was positive, meaning as I go to the right, it will go up. And the degree is 5, which is odd, so as I go to the left, it'll do the opposite of the right side. Now, cross, cross. I forgot to check my y-intercept. It definitely is negative, so it's somewhere over here. So go through the y-intercept, cross through 3 over 2, come down and bounce off that line. Congratulations. See you guys in class.